Have you ever looked out over the massive, expansive, seemingly never-ending sky and wondered why it's always got to be blue? Why not be another color? Perhaps imitate the vegetarian lands and be green, or simply plain yellow? Well, that's what I'm going to explain in today's video. So hey everyone, hope you're well and brimming with curiosity to learn the mystery behind why the sky is blue. But before I get started, make sure to subscribe and turn on push notifications so that you never miss out on whatever crazy, wacky video I'm spinning up with answers to questions you probably didn't even know that you had. Let's get this going. So, what makes the sky blue? Well, if you thought that the sky simply reflects the ocean splashing's color, you're not going to be correct. There's actually an entirely rational reason behind why the sky is blue. I'll start with the sun, or precisely sunlight. See, the sun's rays appear shiny and bright, but in reality, 7 different rainbow colors make it up. And you know what? A renowned scientist, Sir Isaac Newton, has long explained this concept, so let's talk about it. Let's rewind to the 1660s when Sir Isaac Newton discovered that sunlight consists of 7 different colors using a mere prism. He shone the white light onto the prism side, which bent to take the shape of a spectrum with 7 different rainbow colors. Soon after the demonstration, scientists discovered that each color photon travels in a wave pattern. Some of the wavelengths are long, lazy waves, while some tend to be choppy, short waves. Put simply, the order of wavelength from longest to shortest is as follows: red, orange, yellow, green, blue, and violet, or purple. And here's one more thing. Light beams travel in a straight line until they're disrupted, either through mirror reflection or prism bending or scattering. So now the main question arises: what type of disruption causes the sky to be blue? As you might guess, we're gonna chat about that next. So this is known as the scattering phenomenon, and scattering is the only plausible explanation that causes the sky to be blue. But what causes it? The suspended air molecules and gas particles in the atmosphere disrupt the natural white beam and scatter it over the atmosphere. Rayleigh's scattering phenomenon, discovered by Lord Rayleigh, explains this better. During his lab experiments, Lord Rayleigh found out that the scattering rate is inversely proportional to the wavelength. But what does that mean? Well, the simple answer is that the shorter the wavelength, the color beam with a shorter wavelength will scatter more. As you can see, blue and violet have a shorter wavelength, hence the sky is profoundly blue. So now that you're all aware of the phenomenon behind the theory, let's give you a walkthrough of the entire process. But before I move further, if you're thinking that this video is kind of rad, be sure to subscribe, give it a like, or share a reaction in the comments down below. It helps me out and I appreciate it. So this is more or less the entire process in a nutshell. Let's start with when the sun rises and reaches the Earth's atmosphere. Once it hovers over our globe, the tiny air molecules and suspended gas particles collide, or hit, with the wavelengths, hence it starts the scattering process. Usually 1/3 of the sunlight beam is scattered since the diffuse sky radiation, the scattered light beam, reaches the Earth's surface. Since blue is the shortest wavelength, it tends to disperse more than other photon lights, which answers the question of why the sky is blue. I know now you're probably wondering what happens to the other non-blue colors. And what about violet? Isn't violet the photon with the shortest wavelength? Don't worry guys, I'm not leaving you all hanging on a cliff here. So these non-blue colors, why can't we see them? Wouldn't that be great, gazing over a green sky? Well, there's a solid explanation behind this question. The red, yellow, and green long wavelengths of light are mixed and appear as white since they cannot scatter that much. Hence, they are undispersed and directly pass through the atmosphere into our eyes. However, the blue and violet color gets scattered and forms what we see as a vast expanse of blue sky. But why can't we see violet? Because violet gets absorbed by the upper atmosphere, so it never really reaches our gaze. Secondly, our eyes aren't sensitive to detecting violet color. But why is that? See, our eyes' retinas have 3 color receptors: red, blue, and green. Therefore, our eyes are naturally sensitive to detecting the color blue. And here's another fact you might not have noticed. Ever wondered why the sky fades to a white or a light blue color when it steers towards the horizon? What causes that? Well, you see, the light has to further travel through the atmosphere, which has caused the light to scatter and rescatter numerous times. Therefore, due to the excessive scattering of blue light in numerous directions, all we see is a white sun shining directly in our eyes, which of course can be unbearable. So what's the deal with those red sunsets? Well, the picturesque red sunset you adore always has a theory behind it. See, when the sun gets to the lower atmosphere, much of the blue and green wavelengths have been scattered away. Simply, there's little to none of them left for scattering. Hence, we witness orange and red light passing through our eyes since they don't scatter too much. When the air is usually clear, the sunset is often pale yellow. Add pollution particles to it and the sunset appears more of a bright red. And the sun sun over the ocean can also appear orange, all due to salt particles suspended in the air. But hey, that's not all. Ever seen a blue haze over the mountainous regions? It occurs when aerosols, tiny solid particles from vegetation, interact with the ozone layer, scattering hazy blue light across the sky. Similarly, what about the regions with forest fires and volcanic eruption? Well, 500 to 800 nm fine particles get suspended in the air, causing a fiery red sky. Oh, and what about the cloudy white sky? See, particles in a cloudy sky are much larger than the wavelength. Hence, each photon of light scatters equally, creating a white sky. And this raises an interesting question. What about the color of the sky on other planets? We sure have plenty of planets revolving around the universe, but did you ever wonder about the sky on other planets? If you're curious, listen carefully to what I have to tell you. It only depends upon the type of atmosphere existing on the other planet. Let's take the example of Mars, a planet with a fragile atmosphere filled with dust particles and carbon dioxide. These particles spread and scatter light differently than on Earth. Usually, the dust particles absorb the shorter blue light and scatter the remaining color to give a golden yellow hue to the Martian sky. Now, forget Mars. Let's talk about the moon. Nothing but a black sky. So, what's the deal? The moon has an extremely thin atmosphere, non-existent actually, hence there's no collision between gas particles, which explains the black sky. Okay, so you probably get that, but then why is the ocean blue? Enough of the sky, right? So let's conclude our video with another mind-blowing fact. So you understood why the sky is blue, but what about the ocean? What makes it blue? Does it just reflect the sky? You might be partially correct, but no, instead of reflecting, the ocean absorbs the light. But if it absorbs, why is the color blue? Doesn't less absorption mean less reflection? Well, you're right, but let me explain. Oceans consist of uncountable water molecules, making it challenging for the light beam to penetrate the deep ocean water completely. Hence, only the long wavelengths, the red color, are absorbed, and the shortest wavelength is reflected in the ocean, making it appear blue. Think about a glass of water. Why does it have to be colorless? Well, you see, water molecules are less in a glass, and light can completely penetrate it, showing no reflection. In a nutshell, the absorption of long wavelengths leaves blue photons behind. As a result, it's the only color reflected, explaining why the ocean is blue. So let's sum it up. The sky is blue because the air particles in the sky collide with the blue wavelength of the light beam and scatter it in all directions. Now, that's about it for today, so next time someone asks you why the sky is blue, you've got the answer. Hope you guys enjoyed my video. Give it a like and be sure to subscribe to keep learning the answers to wacky questions that nobody will ever even ask you about. And until next time, stay curious.